Hey there, this video is going to introduce us to what is called the conjugate of a pair of terms. And this is a technique that we use when we're dealing with radicals, square roots, as a way to get these square roots to cancel out. So what the conjugate means is if we have two terms added together, like a plus b, the conjugate is what we get if we keep the first term the same, but switch the sign of the second term. For example, if our two terms are 5 plus the square root of 7, the conjugate of those two terms are 5 minus the square root of 7. The reason that this is useful is because multiplying two terms times its conjugate causes the radical parts of the expression to cancel out, which is what we want when we're simplifying fractions. We want to get those radicals in the denominator to cancel out. So let's see how this works. Let's take 5 plus the square root of 7 and multiply it times 5 minus the square root of 7. We've got to distribute and multiply each of these terms times each other. 5 times 5 gives us 25. Square root of 7 times 5 is 5 times the square root of 7. And 5 times the negative square root of 7 gives us negative 5 times the square root of 7. And the square root of 7 times the negative square root of 7 is, well, we could write this like negative square root of 7 times negative square root of 7. Times positive square root of 7. We're multiplying here with a positive times a negative. And now let's look at what happens to all of these radicals. We know that if we multiply two of the same square root times itself, by definition of the square root, that just equals the number we have underneath the square root. So this term is really equivalent to minus 7. So that caused some of these radicals to cancel out. But you probably notice we still have some terms in this expression involving radicals. We've got 5 times radical 7 and negative 5 times the radical 7. But here's where switching the sign in the conjugate helps us out, because if one of these terms is positive and the other is negative but of the same term, positive and a negative of the same number added together cancels out and gives us 0. So we're still left with 25 plus 0 from those conjugate terms in the middle that canceled out, and then we also have minus 7. So in this new expression, all of our radicals have disappeared, and our final answer would be 25 minus 7, which is equal to 18. So let's see this technique one more time, and we're going to cause this radical to cancel out by multiplying times the conjugate. So the conjugate means we'll keep the first term the same, but we're going to switch the sign of the second term and multiply times those two terms. So to multiply times the conjugate of 3 minus 2 root 5, we're going to multiply times 3 plus 2 root 5. We've got to distribute and multiply each term times each term. 3 times 3 gives us 9. Negative 2 root 5 times 3 gives us negative 6 times the square root of 5. Remember that when we are multiplying two regular numbers together, we can multiply those just like we would multiply any integers. We just cannot combine and multiply an integer times a radical. We've got to leave those separate. Continuing our distributing, we want to multiply 2 times the square root of 5 times 3. 2 times 3 gives us positive 6 times the square root of 5. And one more pair of terms to distribute, negative 2 root 5 times positive 2 root 5. If we multiply those numbers together, negative 2 times 2 gives us negative 4. And we also have the square root of 5 times the square root of 5. And when we simplify this, what we should see is that all of these radicals are going to cancel out. The square root of 5 times the square root of 5 is just equal to 5 by definition. So we have negative 4 times just the number 5. And now that we're multiplying two integers together, we can multiply those. Negative 4 times 5 gives us negative 20. There are still some terms that have radicals in the middle here, but since these have opposite signs of each other, when we combine them, they will cancel out. So that just gives us 0, and we still have 9. So our final answer here is 9 plus 0 minus 20, which gives us negative 11. Now you may notice a pattern here. Typically when we multiply a set of two terms times another set of two terms, we need to distribute and multiply all of these terms times all of the other terms. But in the case of multiplying times the conjugate, the terms that we get from multiplying in the middle are always going to cancel out because they will be the same term but with opposite signs, which is equal to 0. So that gives us a shortcut that we can use in the future when we're multiplying times the conjugate. If we want to multiply times the conjugate of this expression to get these radicals to cancel out, we'll keep the first term with the same sign and multiply times the conjugate, which has the sign of the second term reversed. And here is our shortcut. In the special case that we're multiplying conjugates, we only really need to multiply the first set of terms from each pair and the last set of terms from each pair, meaning we just need to multiply these two terms together, and we also need to multiply these two terms together. Now keep in mind, this method is really a shortcut that we're using just in the special case of multiplying conjugates. In general, for multiplying multiple terms, you do need to distribute, but we know that eventually the terms that we would get from multiplying the second term times the first term and the first term times the second term, those will just have opposite signs, so they will cancel out. So this shortcut will save us some time just in the case that we're dealing with the conjugate. So if we multiply the square root of 3 times the square root of 3, that's just equal to 3 by definition of the square root. And if we multiply positive 2 times the root of 5 with negative 2 times the root of 5, positive 2 times negative 2 gives us negative 4. And we also have square root of 5 times square root of 5, but by definition of the square root, that is equal to 5. So this gives us 3 minus 4 times 5, which is 3 minus 20, which gives us negative 17.